Our topic of discussion is speed and velocity. Here we will define speed and velocity, do their calculation, and later see their differences and units. For this, we analyze an example. A car is moving on a road. We want to see how fast the car is moving. For this, we mark 2 points x1 and x2 on the road, which is separated some distance. When the car crosses the point x1, we start the timer t1, and when it reaches x2, we noted its time. In this case, we see that the car takes 5 seconds to cross x2. The car covers a distance of delta x over time of 5 seconds. So, the speed is the distance moved over time t. In this case, distance is delta x, which is from x1 to x2, time is t, and that will be calculated from 0 second to 5 second. So, we mark it t1 and t2. T1 represents the initial time, starting time, and t2 represents the end time when it crosses the final point x2. Mathematically, its definition will be speed equal to distance over time t. Speed is represented with the symbol of nu. So, speed equal to or nu equal to delta x over delta t in this case. We first calculate delta x and delta t. Delta x is equal to x2 minus x1 over delta t will be t2 minus t1. In this case, x2 is at 20 meter mark and x1 is 5, t2 5 minus 0. It will be equal to 15 meter over 5 seconds. We can read it as the car moves 15 meter over 5 seconds. So, its speed nu will be 3 meter per second. This speed is called an average speed. Another called instantaneous speed. The instantaneous speed is the speed at any instant. Now, we move toward velocity. When an object is moving at a speed in a particular direction, that is called a velocity. Velocity is a vector quantity as direction is involved. In this case, it is also represented with the same symbol nu. The best example is an moving aircraft, which is represented in which direction the aircraft is moving. So, equations are same in speed and velocity. So, velocity is defined also with change in displacement over time taken. Here the distance is changed to displacement, at distance with a particular direction is called displacement. So, we can also represent as same delta x over delta t. We can identify velocity and speed when the symbols of delta s and d are used. But this is not hard and fast rule. Keep in mind, always need to focus on the statements. Speed or velocity are the first kinematic equations which are extensively used in problems. If we know delta s and delta t, we can calculate the speed or velocity. If we know other two quantities like displacement, delta s and velocity, then we can also calculate the time it can take by the equation delta t is equal to delta s over nu. If we know velocity and the time it takes, then we can also calculate the displacement as delta s is equal to nu cross delta t.